L'Hopital's rule is so handy that we often start applying it everywhere. But mathematics is not about blindly using any formula. Before applying the rule, we must check if its conditions are satisfied or not. And remember, even if we can apply L'Hopital's rule, it may not be the best choice. If a simpler method works, we should use that. In this video, we will learn that where to apply L'Hopital's rule, where not to apply L'Hopital's rule, and how to use it wisely. Let's just try to evaluate limit x goes to infinity x over x plus sin x. When x goes to infinity, this goes to infinity, x also goes to infinity. Sin x just oscillates between -1 and 1. Before this quantity, this is very small, so this whole quantity will go to infinity. So this is in infinity over infinity form. So let's apply L'Hopital rule. LH, limit x goes to infinity, derivative of top which is 1, derivative of bottom 1 plus cosine x. When x goes to infinity, this one is fixed 1. Cosine always oscillates between -1 and 1. So this whole quantity, add 1. So this whole quantity will oscillate between 0 and 2. So this number oscillates. This does not go to any finite number, or it doesn't become infinity. So this limit oscillates. So this does not exist. But there is a mistake. This limit actually exists. How? See, limit x goes to infinity, x over x plus sin x, just divide top and bottom by x. So what you get? This becomes limit x goes to infinity 1 over 1 plus sin x by x. When x goes to infinity, this is 1. This quantity will go to 0 because this is a finite number. This oscillates between finite numbers -1 and 1, and this becomes large and large. So this whole quantity, this quantity goes to 0. So all this quantity will go to 1 over 1 plus 0, which is 1. So what is the mistake? The mistake is we can't apply L'Hopital rule here, because we have seen the condition that the limit must exist, or it can become infinity or minus infinity. But here limit oscillates, does not exist. Therefore there is a flaw in this step. So you can't apply L'Hopital rule blindly. You should be careful when your limit oscillates. So this is one example where L'Hopital rule failed. You have many examples of this type where the limit of ratios of derivatives does not exist when it oscillates. In those cases you can't apply L'Hopital rule. Clear? Next, I will give you an example where you can apply L'Hopital rule, but it will not give you any fruitful result. It will just make you fool. Let's see this example: e to the power x minus e to the power minus x over e to the x plus e to the power minus x. When x goes to infinity, this quantity will go to infinity. Exponential grows in exponentially. This goes to 0 because this is 1 over e to the power x, and e to the power x goes to infinity. So 1 over infinity 0. This is also 0. This is infinity. So this is in infinity over infinity form. Apply L'Hopital. Derivative of top. This is infinity. Derivative of is e to the power x minus e to the power minus x, then times -1, which is e to the power x plus e to the power minus x. Here you have e to the power x, then derivative of e to the power minus x is minus e to the power minus x. Again, this limit is also in infinity over infinity form. Again apply L'Hopital. You will get derivative of top e to the power x plus, this is minus e to the power minus x. This is e to the power x plus e to the power minus x. This is infinity over infinity form. Apply any number of time, you will just cycle around. So here L'Hopital rule will not give you any answer, what we will do? Our question is limit x goes to infinity e to the power x minus e to the power minus x over e to the power x plus e to the power minus x. Just divide top and bottom by e to the power x. What do you get? Limit x goes to infinity. In top we have 1 minus, when you divide e to the power x by e to the power minus x, you get e to the power minus 2x. Here also this becomes 1 plus e to the power minus 2x. When x goes to infinity, this goes to 0. This will go to 0 and this will go to 0. So answer is 1. You have many examples of this type. You can take limit, let's say x over 1 plus x square. Here also this is just a task for you. You can apply L'Hopital rule again and again. You will see that you will you are just cycling around, you are not arriving at any answer. Here also L'Hopital rule fails. And what you have to do, just divide top and bottom by x, you will get the answer. This is just a simple exercise for you. Let's take another example where you can't apply L'Hopital rule. Suppose you have mod x over x, x goes to 0. And clearly you can't apply because the functions are not differentiable. For L'Hopital rule, our functions must be differentiable. We must find the derivative of function. At 0, mod x is not differentiable. So L'Hopital rule fails. L'Hopital rule can't be applied. You have many such examples. Let us take another. Suppose you have limit x goes to infinity, and you have let's say 40 times x to the power 56 plus x to the power 61 minus 221 x to the power 3, and in bottom you have 203 x to the power 61 minus x square plus x to the power 5 plus 21. Here the top and bottom goes to infinity because dominating terms are this one, and they will go to infinity. So your limit is in infinity over infinity form. But don't apply L'Hopital rule, because you have to apply L'Hopital rule 61 times. You have the easy method, just divide top and bottom by x to the power 61. You will get that the answer is the coefficient of this one, which is 1 over 203. Answer is 1 over 203. And when you have rational functions, polynomial over polynomial, it will be better to not apply L'Hopital rule, just divide the highest power of x, and you have x to the power n goes to infinity for all n bigger than 0. You can apply this limit. This goes to 0, sorry, when x goes to infinity for every n positive. So you have to be careful for the limits where you should not apply L'Hopital rule. If you see any such examples, then comment in comment section and let's have fun trying all those limits.